Today in class, we worked on Lesson 2 in Unit 7, Food at the Fair, where we explored how adding and subtracting linear functions impact the key features of those functions. In the Ready section of tonight's homework, you're asked to add and subtract linear expressions, and we're going to do that by combining like terms. If we look at the first problem on the left, we see that we have two linear expressions, and we're going to rewrite those without the parentheses since we're adding them, and then we're simply going to combine the like terms. Remember, terms are the parts of the expression or equation that are separated by addition and subtraction. So in this case, we have four terms. Two of them have the variable x in them, and then two of them are constants. It's important to remember that the operation that's in front of the term goes with that term. So when we combine our x terms, we have 9 x's altogether. And when we combine our constants, we have negative 12 plus 15, which is positive 3. Looking at the second problem, because we are subtracting these linear expressions, we first need to distribute that negative or negative 1 to each of the terms inside the parentheses in the second linear expression. When we do that and remove the parentheses, we're left with 8x minus 12 minus 15 minus 1x. Again, we are combining our like terms, or the terms with the variables first. We have 8x minus 1x, which equals 7x. Next, we will combine our constant terms. Negative 12 minus 15 is negative 27. Here's another example in the Ready section. This one is a word problem. Barb is charging $40 to get into her club. That is a flat fee. And then for each event that an individual wants to attend within the club, she's going to charge $10. Janet is charging a flat fee of $25 just to get into her club, and then she's going to charge $20 for each event that an individual wants to attend once inside that club. First, we're going to write a function to represent the total cost for each club. The first function, Barb's function, is b of x equals 40, which is our constant. That's the amount that she's charging, the flat fee, just to get into the club, plus $10 per event, and x is representing the number of events that an individual will attend. When we look at Janet's function, j of x equals $25, that's her flat fee, 25, plus $20 per event. Again, x is representing the number of events attended. And if we want to look at the total cost that would represent admission into both clubs with an unknown amount of events being attended, we would need to add both of these functions together. Just like in the previous example, we're going to add our like terms. So we're going to have the function t for total, t of x equals 65. That's the sum of the 40 flat fee for Barb and $25 flat fee for Janet, plus 30x. And again, we're adding that 10x plus the 20x. If we are comparing the costs and looking at the difference in the prices, we're going to subtract the functions from one another. D for difference of x equals 15, which we get from subtracting the 25 from the 40. And when we subtract 10x minus 20x, we're left with a negative 10x. So we have the function d of x equals 15 minus 10x. In the set section, we are combining linear functions and determining features of the graphs. So now we're starting with these linear functions, and we're looking at them on the graph. When we're looking at f of x, we know that this function is in slope-intercept form, and we know that the coefficient is the constant rate. We looked at that in yesterday's Ready, Set, Go homework. And we know that the constant is our y-intercept. So if we're looking at this one on the graph, it's represented by the red line. We have our y-intercept. That's where our line or our function intersects the y-axis. So we're starting at -2, and our slope has a change in the y values, or a rise of 1, and a change in the x values, or a run of 4. So in order to get to the next point on our line, we're going to start at our y-intercept -2. We're going to rise 1, and we're going to run in the positive direction to 4. And then if we rise 1 again and run 4 more over, we'll hit the next point on the line. Likewise, if we were to drop down 1 and go to the left in the negative direction 4, we would hit another point on that line. The blue line represents g of x. Our y-intercept here is +3. That's where we're starting. Our slope is 1/4. So again, we're rising 1, and we are running in the positive direction to 4. Or our y values from this point to this point are changing by 1. And our x values from this point to this point are changing by 4. So we're rising 1, running 4. Rising 1, running 4. And so what we see is that we have the same slope for both functions, and we know that when we have two functions with the same slope that have different y-intercepts, they create parallel lines on a graph. So when we look at the sum of these two functions, we're going to do exactly what we have done in the previous examples, which is to combine our like terms. So we have two terms that have variables, and then we have two constant terms. When we combine our 1/4 x and our 1/4 x, we have 2/4 x, and when we add -2 to 3, we end up with +1. If we simplify that 2/4 to 1/2, we notice that this slope is not the same as the slope from our initial functions before we added them. Because the slope is different, we know that the sum of the original functions is not going to be parallel to the initial functions. When we graph this function, we're starting with our y-intercept, which is at +1, and our slope, 1/2, our change in our y values to get from the initial point, which is at +1 on y, to our next point on our line. We're going to rise up 1, and we're going to run 2. Rise up 1, run 2 to get to the next point, and continue on there. And finally, when we look at the Go section of our homework, we're being asked to write an explicit linear equation that models the situation. So we are writing functions in the context of the situation. Sarah is going to put on a charity concert. She gets a total of $3,500 from her biggest supporter, and then also makes money when people purchase tickets for $3 each. Y is representing the total income. Our initial value is $3,500. And she's earning $3 per ticket. So X is representing the total number of tickets sold at $3 a piece. So we know that we're going to multiply those two together, and that is our function.